Hi AB Calculus class. This is 2015 question number 1. This is our last ETLT question topic for the day. If you have not done so, I highly recommend stopping the video and watching the video that I posted on ETLT questions. Look at it, see all the steps, and then see if you can take that and apply it here. Okay? Alright, so in this question, my first job is to type these two into y1 and y2 in the calculator. So this is in y1, this is in y2. And the second thing is to determine what's my ET and LT. So this is my ET, my entering rate, the rate that water is entering into the pipe, and this is my LT. So this is ET, this is LT. The only reason I do this is so now I can match up the notes, the concepts, with what I'm trying to apply it with here. Alright, let's jump into part A. Part A says how much rainwater flowed into the pipe. How much entered? So the area underneath the entering rate tells you how much entered. So we just want the area from 0 to 8 of the entering rate. Here the entering rate is RT. So I'm going to pull out my calculator. Now the AP exam, they could throw this question out there, but without a calculator, you'd have to take the antiderivative by hand. This one's not one you can take the antiderivative by hand though. So I'm just going to hit Math 9 from 0 to 8. And then I'm going to take RT and plug it in. Now I am using hotkeys. Since this is in Y1, I'm just going to use my hotkeys and plug in Y1. And I get the answer of 75.5703. Do they ask for units? Nope. I mean, they tell you it's cubic feet of rain water, so feet cubed. Okay, that's part A. Alright, part B. Alright, for part B, is the amount of water in the pipe increasing or decreasing at time equals 3? We talked about this. If ET is greater than LT, the amount is increasing, and if ET is less than LT, the amount is decreasing. We've described this before using water. So over here I'm getting my water cup. If you've seen this before, stop me. No, I'm just kidding, don't stop me. If ET is greater than LT, entering rate is faster than leaving rate. If you're pouring things in faster than it can drain out, the amount is going up, increasing. If it switches and the LT is now greater, things are leaving faster than you can pour it in, the amount decreases. So we just need to know which is higher, ET or LT, or the entering rate and the leaving rate. So specifically in this problem, they want to know what's going on at time equals 3. So I want to find R of 3 and D of 3. So I'm going to use hotkeys. Since this is in Y1, I can hit alpha trace Y1 and then ask it to plug in 3. All I'm doing is plugging a 3 in there, and I get an answer of 5.0863. And then D of 3, that's in Y2, so alpha trace Y2, and I'm going to plug a 3 into there, and I get 5.4. So the leaving rate is greater than the entering rate, so I could say because D3 is greater than L3, the amount is decreasing. You could have also subtracted the entering rate minus the leaving rate and got a negative net rate. Alright, I think that's it for that question. Alright, part C, part 3. At what time is the amount of the water at a minimum? Okay. So when is something at a minimum? Alright. If the entering rate is less than the leaving rate, the amount's decreasing, so it's going down. And it switches, and then the entering rate is greater than the entering rate, so it's now increasing. So when the leaving rate's greater, it's decreasing, and then the entering rate's greater, it's increasing. Down here, that's where that minimum is. So the minimum will occur or can occur at the critical point when ET is equal to LT. Okay, so who can win the absolute max or min awards in this question? Endpoints or critical points? So we have time equals 0. Whoa, whoa, whoa. We've got the other endpoint, time equals 8. And we need the critical point. Now, if you're wondering, Mr. Pygott, what's all this AT stuff about? At any time t, the amount is the initial. They tell me in this problem initially there's 30. Plus how much we gain from time 0 to t. This tells me how much entered if I use r of t. Now instead of t, since I put a t there, I have to put an x. So the initial plus how much water flowed in minus how much water flowed out. This right here in the area underneath the leaving rate tells me how much flowed out. Okay, so this will tell me how much water there is at any time. Okay, I want to know the critical point. The critical point is where the derivative equals 0. Well, the derivative of 30 goes away. The derivative here, derivative destroys the antiderivative, and here's r of t. And derivative destroys the antiderivative, and we have d of t. So your critical point occurs when r of t minus d of t equals 0. Or if you added it to the other side when the entering rate equals the leaving rate. So there's two ways of doing this. One way is to graph this in y1 and y2 in your calculator and find out when they're equal. Since they're already in y1 and y2 in my calculator, I'm going to do that. So I'm going to hit zoom 6, my standard graph. And I hope I can see this. Okay. I had to change my window a little bit, but if I do, and if I see where these two intersect, I get that these two intersect at time 3.2716. So this minus this equals 0, or r of t equals d of t. The answer to either one of these is at time 3.2716. So over here, this is my critical point, 3.2716. Okay, so let's go ahead and find the amount of water when it's at the minimum. So at what time is the amount of water at the minimum? And one way of doing this is to find these values. So how are we going to find, oh by the way, if you wanted to solve this way, you would just do this one minus this one, graph, and look for the zeros. Where does the graph cross the x-axis? Anyway, so I'm going to take this 0 and ask myself, how much is there at time 0? Well, I already know at time 0 there's 30. You could put a 0 here. The area from 0 to 0 is 0, 0. It's the initial. Then I want to know this. So I've got to go ahead in my calculator and do some work. So I want to know how much is there at time equals 3.2716. So again, I do 30 plus, math 9, type this in. It's a lot of work, but if you do all the work, you get the answer of 27.9645. And then we need to know how much is there at time 8. So if you plug in an 8 and an 8 and you type all this into your calculator, again, it takes a lot of work, but you get 48.5436. And if you look at your values, there's 30, then there's 27, and there's 48. So this is the minimum. So to give my answer, at time equals 3.2716, the minimum amount of water is 27.9645. Now, there's one small thing about this question. You actually did not have to plug all of these in. Okay? If we go back to here, you see where we have a prime t? We can actually make a sign chart of a prime t. So if you made a sign chart of a prime t, and you graphed this minus this. So if you graphed this minus this, and you got 0 and 8, and you got that 3.2716 number, if you graph this, the graph will go minus and then positive. Now, what does this tell me about a of t? If a prime t goes from negative to positive, that meant a of t, the amount was decreasing until increasing. And in the problem, they actually did not want to know how many gallons. The only thing they wanted to know was the time. That was it. And instead of having to do all this work to show the time, if you would have made a sign chart, you could have said a prime t went from negative to positive, was negative from 0 to this, and then positive from this to this. Therefore, at this time, it was not just a relative minimum, it was the absolute minimum. All right, let's do part D. Part D says the pipe can hold 50 liters of water. So the water continues to flow in and out of the pipe. Right, but do not solve an equation involving one or more integrals when the pipe will begin to overflow. Well, the pipe will begin to overflow when the amount of water is 50. So we're going to do part D. Oh! That was part C, and I never wrote it down. Bad Pyget. Okay, well anyways, we're at part D now. So for part D, we're going to erase all this stuff. And we're going to go back to our work here, where we had 0 to t and 0 to t. This told me the amount at any time t. There was 30, the initial, plus how much we gained minus how much we lost. And we want to know, when will this be equal to 50? Remember, it overflows at 50. So the question is, well, when will the amount hit 50? So we replace a of t with the amount 50, and that's all they want. They want an integral, a problem with an integral, an equation that we could solve. Now, they don't want us to finish it. This is it. We're done. But that was a of t. We replace a of t, the amount, with 50, and now we have an integral. And if we were able to solve that, that would tell me when, at what time would it overflow if it can only hold 50. All right, that's it for that question. See ya.